we have z1 is equal x1 plus I y1, and we have z2 that is equal x2 plus I y2. So in the algebraic form, the sum of these two complex numbers is going to be z is equal, okay, let me write down this way. Z is equal z1 plus z2, and this is equal x1 plus I y1 plus x2 plus I y2. This is going to be equal x1 plus x2, so real numbers together we are adding, and taking common factor as imaginary number, I times y1 plus y2. Okay, so let's see how we are going to do example. We have, let me see, what do I want to take? I'm taking z1 is equal -1 minus 3i, and we have z2 is equal 3 plus 2i. Okay, so z1 plus z2, it's going to be, first we are adding the real portion, right, of these complex numbers, which is going to be -1 plus 3. Let me show you here, -1 and plus 3, right? And so we are going to do plus I times y1 plus y2. Here this y1 is -3 and y2 is +2. So it's going to be -3 plus 2. And the answer is 2 minus I. Let's do one more example. Example 1. We do example 2. Okay, so what do we have in this case? z1 is equal -1, z2 is equal I. Well, in this case, it can be easier than that. z1 consists of only real portion of the complex number, and z2 consists of only imaginary portion of this number. So at this point, z1 plus z2 is equal, so -1 plus I. That's all. Okay. Let's do now subtraction. Next we are going to do subtraction for complex numbers. So subtraction of complex numbers is also done in algebraic form. So the difference of two numbers, z1 is equal x1 plus I y1, and z2 is equal x2 plus I y2 is equal z1 minus z2. Subtraction we are doing is equal x1 plus I y1 minus x2 plus I y2, and this is equal x1 minus x2 plus, taking I out, y1 minus y2. Okay, let me put here subtraction. Okay. So let's solve example. That's going to be the only example because it's all of them are being solved the same way. So we have z1 equals 17 minus 35i. z2 is equal 15 plus 5i. Okay. So the real portion of z1 is 17. Imaginary portion is negative 35i. The real portion of z2 is 15. So both of them are real. So those are real portions. And these are negative 35 and plus 5 are imaginary portion of the complex number. So if we subtract, we are going to get z1, z1 minus z2 is equal 17 minus 15, right? Minus 15. I am putting in parentheses only for visibility, readability. Otherwise, I don't need to put in parentheses. I times negative 35. It's going to be minus 5. Okay, let me do this way. Okay, I'm going to put this way. Minus negative minus negative 35i minus 5i, right? Plus 5i, yeah. Okay, so from here, what do we get? This is equal to, right? So opening parenthesis, I'm going to get, since negative 35 will become positive, I'm taking I out, and I will get negative 35 minus 5. And the answer is z1 minus z2 is equal to minus 40i. So this is the answer. 17 minus 35i minus, it's going to be the 15 plus 5i, right? From here, we have 17 minus 35i minus 15 minus 5i. So, like terms, 17 minus 15, it's going to be equal to, right? z1 minus z2. And negative 35 and negative 5i, it's going to be minus 40i. And this is our answer. Moving to multiplication. Multiplication. Okay, so we have what is it? Z1 is equal x1 plus I y1. z2 is equal x2 plus I y2. So if we multiply z1 times z2, it's going to be equal x1 plus I y1 times x2 plus I y2. So let's start distributing. What we're going to get? So first we multiply x1 by x2, and then x1 by y2. So it's going to be x1 times I y2. Next, I y1 times x2, it's going to be plus x2 times I y1, and I y1 times I y2. So it's going to be plus I squared times y1 y2. Okay, so the result is going to be the following: x1 x2 minus, where is the whole portion? This one. So this is real number and this is going to be real number, with the difference that I squared, right? Let me use this one. We know that I squared is equal -1. So which means we are going to get minus y1 y2, right? So this is going to be the portion of real number, and plus, taking I out, we are going to get x1 y2 plus x2 y1. So we have two choices. So when we do multiplication, so we can multiply everything from the beginning, just like I did now here, or just follow this template. That's all. All right? So I'm going to follow template. What do we have? We have z1. So example, z1 is equal 1 minus 5i. z2 is equal 5 plus 2i. From here, z1 times z2 is going to be equal x1 times x2, which is going to be 1 times 5, right? It's going to be 1 times 5, and minus y1, y2, y1, -5, and plus 2. So it's going to be -5 times 2, right? Okay, this is our whole portion. Okay, next, plus I times x1, y2. x1 is 1, y2 is 2, plus x2 is 5, and y1 is -5. I guess it would be a good idea, I just would write down here, x1 is equal 1, x2 is equal 5, y1 is equal -5, and y2 is equal +2. And that will clear any possible questions. So from here, z1 times z2 is equal, what do we have? This is 5, right? This is minus -5 times 2, 5 minus 10. So it's going to be the 5 minus -10. So it's going to be +15. Next, 1 times 2 plus 1 times 2 is 2, and 5 times -5 is 25. So Negative 25 plus 2 is negative 23. So we get minus 23i. And this is going to be answer for multiplication. For the product of complex numbers in trigonometric form, okay, the equality is true that z1 times z2 is equal r1 times r2, r2 times cosine phi1 plus phi2 and plus I times sine phi1 plus phi2. I just saved you time and instead of going step by step all multiplications. Okay, so as we know, trigonometric form is the following. Z1 is equal R1 cosine phi1 plus I sine phi1, right? And Z2 is equal R2 times cosine phi2 plus I sine phi2. If you multiply by each other, you are going to get this result of Z1 times Z2. Okay, all you have to do, take the given values for phi1 and phi2, R1 and R2, and follow this template. Okay, and for the product of complex numbers in exponential form, it's going to be z1 times z2 is equal r1 times e to power I phi1 times r2 times e to power I phi2, and this is equal r1 r2 times e to power, following the rule of the exponent, properties of exponent. If you multiply exponents with the same base, what you have to do with exponents, of course, you add them, right? So it's going to be e to power I phi1 plus I phi2. And from here, we are getting r1, r2, e, taking I out, and we get phi1 plus phi2. Okay? Oops. Funny, huh? How I put the parentheses. All right. So let's do one example with exponents. So we have z1 is equal square root 2 e to power half a pi times I, and z2 is equal square root 2 e to power negative pi over 4 times I. Okay, the product of these two complex numbers is going to be z1 times z2 is equal r1 r2 e to power I phi 1 plus phi 2. So what do we have? Square root 2 times square root 2 times e to power phi 1 is pi over 2, and phi 2 is negative pi over 4. That's why instead of addition we do subtraction here, because pi over 4 is negative. So this is equal to, because square root 2 is 2, e to power pi over 4 I, because pi over 4 is a half of pi over 2, right? If you pi over 2 minus pi over 4, you get pi over 4. So from here, the answer is z1 times z2 is equal to e to power pi over 4 I.